Hi, welcome to our presentation. So we're going to talk about NIB's journey to the cloud, so using Snowflake and dbt. So NIB's been around since 1952. It's a trusted international health partner. So we're about empowering our members to make better decisions and improve health outcomes through greater accessibility to affordable health services and information. And so we sell travel insurance, medical insurance, and health insurance, and we're a global company. So my name is Pip. I'm an analytics engineer in our emerging technology and data platforms team. So today I'm going to be talking about a bit about DBT, some testing and linting.
And hi, I'm Jules. I'm a engineer here at NIB, and I'll be talking about our overall data vision and how we're using Snowflake and also pipelines for CI/CD. So our overall vision is that we want to move away from using data as a service and to work with data as a product, which means that we want to work with and own data in a distributed way and enable self-service for every data user in the company. So that means that we have a pretty huge set of challenges. It means that we need our data to be high quality and highly available and discoverable, whilst also making sure that we're securing sensitive data, including private health data and also our financial data. So how do Snowflake and dbt fit into this? Let's have a look. This is our tech stack, and like most organizations, we have an ever-evolving constellation of data solutions with a mix of legacy systems as well as applications and serverless microservices. We land all of this data in S3, which is our data lake, and Snowflake is the environment in which we host our data mesh architecture. In the data processing and analytics side, we use dbt as our transformation tool, and on top of that, we use different tools for analytics and reporting depending on the use case. Underlying all of this, we use GitHub and BuildKite for our version control and CI/CD, which helps us to bring software engineering and DevOps best practices into the data space. So, Snowflake. Snowflake, if you haven't heard of it yet, is a cloud-based data warehouse. For us, it's the meeting ground between our data producers and our data consumers, hence the data mesh architecture. So what we like about it is that it's built on familiar conventions, it's got a simple UI, and it scales well and lets us iterate quickly without worrying about things like concurrent use or sizing. And from a data engineering perspective, it's really easy to land data and also create patterns. So we are finding it pretty easy in terms of also managing permissions and features that it offers in privacy access control. So how do we get data into Snowflake to begin with? So we have two main ways of getting data into Snowflake, essentially Snowpipe or Fivetran. With Snowpipe, we have all our operational systems which use Snowpipe dump the files into S3 as landing zone, and then we have a Kinesis Firehose set up so that if the S3 bucket finds a file using the S3 event notification on a given bucket prefix, then it will notify the Snowpipe service, and Snowpipe will land data into Snowflake in a given landing table. We have a really nice setup for this where we have a Dockerized application which will set up the Firehose event notification and Snowpipe for you if you set up a YAML configuration for it. And the great thing about that is that you get it in a really nice and consistent format, turns up within minutes, and there's some built-in deduplication based on file names. So one downside that we have experienced so far with this is that it can be a little bit tricky with S3 bucket notifications because sometimes they can clash and override. So eventually we're going to try and move towards using event bridge notifications, but we're still thinking about that because that can introduce some latency. The other way that we have getting data into Snowflake is Fivetran. So Fivetran's really nice. It has some built-in integrations for a large number of data sources already, including Snowflake, including Salesforce and DynamoDB. And this is particularly good for getting data from one of its supported sources, particularly if you want to iterate really quickly, because it's really easy to set up a connector and make sure that everything's coming through. So that's how we get data into Snowflake. Let's have a look at how we're securing the data once it gets there. So with Snowflake security, we want to work together with a large number of users across a number of different disciplines. So we need to make sure we're managing access and ensuring we're following the least privilege principle. So we manage Snowflake permissions using Okta and Snowflake Roles. Okta is our identity and access management service. We also, on top of Okta, have an external authorization process for new users to let them access Okta in order to access Snowflake. Once they're in Snowflake, we have a number of different Snowflake roles set up, which we assign to different users depending on the tasks that they need to undertake. So we have a general deployer role, which has basically all the permissions, but we barely give access to anybody for that role unless they need to make a deployment. Other roles that we have include sysadmins, data engineering, data warehousing, and also business users, each role having a smaller subset of permissions based on the tasks that they need to undertake. All of this we manage using a central repository where changes to role permissions need to go through a approval process, which is nice and transparent. So some of the issues that we've experienced with this are that permissions groups sometimes grow so big that they kind of defeat the purpose, or you have sometimes the other problem where you have so many small roles that they require switching in between them when you're in Snowflake. But generally, we found that Snowflake makes it easy to manage the permissions. In terms of privacy, Snowflake also offers encryption of data at rest, as well as things like masking policies. We're still working through the broader issues of how we want to achieve end-to-end encryption and also anonymize data for data analytics. But overall, Snowflake is really handy in that it offers a number of access control, encryption, and other tools that support our overall data security picture. So, Pip will talk about DBT and how we use it for transformations.
Awesome, thanks, Jules. So DBT, so it's short for Data Build Tool. It's a command line tool using SQL code. So it's produced by DBT Labs, formerly known as Fishtown Analytics. So as an analytics engineer, this is a key part of my toolkit. So if this was presented in real life, I'd sort of ask how many people have heard of it. I mean, maybe a bit easier question is how many people haven't heard of it. So there's a lot of articles and things going on around it at the moment. So there's two different formats with DBT. So we've got DBT Core, which is an open source command tool, and DBT Cloud. So we use DBT Core, which we load up in VS Code and with the Snowflake warehouse in the back end. It's pretty awesome. So we were traditionally a ETL shop, so extract, transform, then load to our data mart. However, that would potentially, just to get yesterday's data, would take almost all day just to finish. So in the new world, the cloud world, storage is cheap. So the norm is now to extract, load, and then transform the data so we can just store it there. So DBT looks after that T in ELT, the transform process. So it doesn't extract or load the data, but it's really good at transforming it. So things that are already loaded into Snowflake. So now it's just up to Jules to worry about getting that data into Snowflake for me. So the process when we land everything in Snowflake using DBT, it's just been awesome. So while we don't have all of our legacy stuff there yet, we've seen some massive gains. So one example, a monthly process that used to take about 8 hours to run, had millions of lines of data, was reduced to about 30 minutes using Snowflake and DBT. So that makes it a lot more rerunnable if there's a problem. You don't have to say, oh, sorry, we've got to wait till tomorrow. So DBT is growing organically at NIB. So we're always having new people contacting our team wanting to jump on board. We've set up some DBT mentors to help with this, and we have a Slack channel as well. So it's like a DBT guild where people can ask questions, help each other, share interesting new features. They have great articles around the place. DBT also have their own Slack domain that has an amazing community. So everybody's really helpful to help with questions in there if you get really stuck. So DBT uses SQL coding and Ginger, which is a templating language. So SQL seems to be becoming sort of the code of choice again for data warehousing. So there's this movement back towards code-based tools rather than the GUI-based systems. So this potentially allows easy switching between tools as business needs change. DBT Lab's premise behind DBT is about having reusable code. So they use the thing that's called the DAG. It's kind of like the diagram lineage tool, and a way to review this to make sure that you're not repeating things from your source. So setting up projects where you just pull out the data from the table once and then everyone can use that same table for their requirements. So, software engineering and DevOps best practice. So, things like having standards, code structures, style guide, there's documentation. So, DBT has built in DBT docs, which Jules will cover a bit later. So, we're currently in the process of debating our standards. It's a work in progress, but I do love a good set of rules, so I'm pretty motivated to get that sorted. Another thing that's been good, instead of having things that I'm sure you've all had, like the final version instead of just the final version, having the version control and easy to find that revision history using Git. The CI/CD, never knew what this was, but now definitely do. Continuous integration, continuous development. So again, we're using Git branches to be able to do that so that we can all have our own separate areas to work on. And part of our process, we enforce a peer review before going to production so that it makes sure that things are not sneaking through, that people are definitely got another set of eyes over that. So I'll hand over to Jules now. She's going to talk some more about our pipelines.
Thanks, Pip. So we use fairly standard continuous integration pipelines and environments. We have the dev, test, and prod environments. And in Snowflake, these are basically just different databases. In DBT, we have different targets that we point to for dev, test, and prod, and also different roles that we use to access each of these different databases. So this is really powerful because this means that we have a standard template pipeline and also standard sort of utilities and stages which we go through in each of our pipeline steps. And individual DBT projects which we have can customize these steps depending on their needs. So this allows different teams to work across different projects with a common framework. It means you can hop between different repositories and have a basic idea of what's going on. And it's great because just having the same general process is really handy. So our pipeline tool that we use is BuildKite, which I personally love. It means that you can hook up to automatically build any DBT projects that you have on a push to GitHub, and it has the standard steps for each of these builds, including obviously building the project, linting, and then usually we have a step where you can view the result in the Snowflake test database before you promote to prod and generate any documentation. So the great way in which this lets us work together simultaneously is that we can all work on our individual branches, which ensures the integrity of the main branch. And a pattern that we found useful for this is that we append the branch name to the schema or the model in DBT, and then you can do that by overriding the default DBT naming macros. And then when we push, the branch is automatically built by BuildKite in the test environment. And because the branch name is across everything, it allows us to identify which objects belong to which particular ticket. We also have some automated cleanup scripts, which are pretty handy, which destroy any non-main branches based on the name after a certain amount of time has gone by. We also find that Snowflake zero copy cloning is pretty handy. Zero copy cloning, if you haven't heard of it before, is when you make a reference to an original object, such as a table or a schema, rather than making an actual copy. So in Snowflake, this only contributes to data storage costs if you modify that object afterwards. And DBT projects which rely on larger tables or views or have a fixed set of sources, we tend to make a zero copy clone of the main production table in dev and test. And this is great because it's efficient, it's cheap, and it lets us work with an up-to-date representative data set, which actually matches production. So Pip will talk a bit now about how DBT and Snowflake support data quality through linting and testing.
Great, thanks, Jules. So testing. So DBT comes with some built-in testing, as well as they have some great documentation on how to build your own custom tests. So while we have done data testing in the past, it's usually after everything's loaded. So any issues that pop up means perhaps a lot of time to rerun things. So even simple testing, like testing that the unique key is unique. Yes, I'm sure we've all been there where they're not unique, and freshness tests as well to check that your data is coming through. The monthly process that I mentioned a bit earlier is an improvement we've made, has also been incorporating the tests into DBT. So comparing like the final data set sums against the original source and against some comparison data sets. So our data analysts have estimated that's probably about 2 days worth of work of trying to get the manual validations. Excuse me. So the pipeline will fail if the tests fail. So it will warn us if something has gone wrong, just in terms of if it's outside of the thresholds that we've set for it. So linting, another favorite of mine. So part of SQL becoming more common and with the DevOps standards, there's a tool that can help called SQL Fluff. So SQL linter basically tidies up your code based on some standards. So I've just provided a small example there, over exaggerated, of course. I would hope nobody would write code like this, but hey, you never know. We've implemented this linting process in our pipeline. So at this stage, it's a warning rather than a failure, but it will be, as we get our standards sorted, it will be something that we'll probably enforce more strongly in the future. So now I'm going to hand over to Jules again. So she's going to chat to us about documentation.
So, docs. Well, DBT projects come with built-in docs, and as you can see on the screen, it's basically a pretty good format. You can generally see a lineage graph and also some details about each of the tables and views and what it contains and that sort of thing. And one of the great things is that it's all in one place. But if you have a large number of different DBT projects, this can be scattered around. Something that we found useful is because we work across a number of DBT projects in a pretty decentralized manner. We have set up a central repository for docs, which we call DBT Megadocs. It's basically just one DBT project that aggregates all the docs for all of the DBT projects, which we find overall a pretty valuable tool because it helps us track down different data sources and who's using it, and also where different data sources have come from. So that's pretty much it. We'll have a talk about future challenges. So future challenges, obviously, I think every organization has a large number of challenges at all times. For us, the things that we want to do are to keep building on what Snowflake and DBT provide us in terms of tools, because they are helping us make our data more accessible, and they act as this platform and this common language bridge between all of these different teams. But they also come with a number of different challenges, which we have yet to figure out how we're going to work them in to solve. So some of them are improving our data lineage and discoverability, making sure that our docs are also consistent and complete is one part of that. We also want to make sure that we're thinking about privacy and anonymization sort of end to end, and we need to think about whether or not we encrypt data, before it reaches Snowflake, and how we do analysis on it afterwards. If everything's encrypted, whether or not we unencrypt, that sort of thing. One other thing that we want to do is we want to take this cultural shift of distributing data ownership more and more, and getting everybody comfortable with the idea of self-service by making Snowflake the go-to place, and DBT really well understood across the organization, and also doing things like fixing permission creep and balancing our privileges with security, and also just establishing more conventions and consistency across both of those tools.
So our key learnings through onboarding with these tools. So Snowflake enables standardized data pipelines. Snowflake also is really good at balancing permission scope and the security requirements. Using DBT with automated pipelines, so we're using with build, kite, and Git, so using the CI/CD best practice, using linters and DBT docs just to keep things nice and organized and tidy, and the integrated testing has been great for us. So we're keen to hear any questions that you've got. So fire away.